Welcome back. Wassce PC2 2025, which is the private candidate. That's the second batch of deck exams called mathematics. Let's see this beautiful question. A sector of a circle of radius 21 centimeters subtends an angle of 120 degrees at the center. If the sector is cut and folded to form a cone, find correct one decimal place. The radius of the base, perpendicular height of the cone. We are to take pi to be 22 out of 7. Now, don't forget we have two types or two kinds of sectors. We have the major sector, and this is the diagram for major sector. Then we have the minor sector. But this question didn't state either we are dealing with what? Major sector or minor sector. So if you don't see these two, whether you are dealing with major or minor, you take the question as a minor sector. Take note of that. You take the question as a minor sector, then you work with it. So now we have a minor sector here. So this is a minor sector. That's a minor sector. So it's a plane shape, and this is a minor sector. That's a minor sector. So a sector of a circle of radius 21 centimeters. So now let's see our minor sector. So this is our minor sector, and this is the radius. And this too is the radius. Don't forget that the radius are what? The same. And this is our minor arc. That's the minor arc, the length of the minor arc. And this is the radius. So now, if the sector is cut and folded, so we are to fold this sector. Don't forget, this is the radius, this is the radius. So when you fold the sector, which means that the two radii will coincide. So which means that the two radii will what? Will coincide, which means coincide means they what? They will meet. If they meet, they will form the length of the slant height of the cone. So this is what we have. So when the two radii, when they coincide, they will meet to form the slant height of the what? Of the cone. So this is a cone we have here. And now, the length of the minor arc will now tend to be what? The circumference of the what? Of the base of the cone will now tend to be the circumference of the base of the cone. So take note, we have two things you have to note here. One, the two radii will coincide, and the coinciding we are trying to say that they will meet. The two radii will meet, and now the two radii, when they meet, they will form what? The slant height of the cone. And now the length of the minor arc will now tend to be what? The circumference of the base of the cone. You know that the base of the cone is a circle. The base of the cone is a circle. So now the length of the minor arc will now tend to be what? The circumference of the base of the cone. So take note of these two illustrations. So these are the illustrations we'll be using to solve our lovely and sumptuous and delicious question. So now let's see. So we can deal with solution. So what are we saying here? The radius of the sector. So let me draw the minor sector here. So this is the minor sector, and this is the cone. This is the cone. So we have the slant height, that's L. We can get the perpendicular height, which meets what? The base radius. So which means if the height meets the base radius, we have an angle created, which is what? 90 degrees angle. Now this is the sector, and this is the cone. We mean the minor sector. This is the radius, and we have our angle here. And this is the arc, the minor arc. Take note of that. That's the minor arc. So now what we said is the radius of the sector, will be the same thing as what? The slant height. The slant height of the cone will be the slant height of the cone. And the minor arc will be the same thing as what? The circumference of the base of the cone. So this is what we have. Now, a sector of a circle of radius 21 centimeters. So which means the radius of the sector is 21 centimeters. And if the radius of the sector is 21 centimeters, then it implies that the slant height is also 21. So radius is the same thing as the slant height of the cone. So which means that we can say that we have 21 centimeters. So we can deduce this here. Now, subtends an angle of 120 degrees. So our angle here, theta, is 120 degrees at the center. So let's see the center O. We have a point here A, then let's see B. If the sector is cut and folded to form a cone, so that's the deduction we've done here. This is our sector. When you fold it, it forms what? A cone nicely. The same thing applies to what? A major sector. When you fold it, it will tend to be what? A cone, a nice cone. A nice cone. So now let's see. The minor arc. How do we find for the length of the minor arc? And this is just theta degrees over 360 degrees times the circumference of the circle, which is 2 pi r. And this is for the length of the minor arc, which is for the sector. Now let's see the circumference of the base of the cone. Now check something here. Let's use small r for the sector, and let's use capital R for the base of the what? The base radius of the cone. So now the circumference of the base of the cone is 2 pi, then we use what? Capital R. Now check something here. When we divide both sides by 2 pi, you can see that this guy 2 pi and 2 pi will go away. Then we get capital R to be equal to what? Theta over 360 degrees times small what? R. So this is the deduction we've made here. Now the question says we should get the radius of the base of the what? Of the cone, which is capital R. And our theta is 120 degrees. So we have 120 degrees over 360 degrees times, let's see the small r. The small r is the radius of the sector. The radius of the sector, which is 21 centimeters. Degrees cancel degrees, 0 cancel 0. 12 here, 1 into 36 is 3. 3 to 6, that's 3, 12, 36. We have 3 here, 1 into 21, we get 7. So capital R is just 7 centimeters. So we have the base radius of the cone to be 7 centimeters. 7 centimeters, which is very, very, very simple. If you don't understand, please play back the video for better understanding. So now we have the I part of the solution. Let's see the II, which says what? The perpendicular height of the cone. So let me clean the other part and let's work this out beautifully. Now the question says you should find for the perpendicular height of the cone. And this is the perpendicular height of the cone. So let's see. capital V, and this is the center O, then let's see B, or let me use, let's see, Z. So let's draw our right angled triangle, because the angle inside here is 90 degrees. So we have our right angle triangle shaped like this, which is capital V, then capital O, then capital Z. The slant height L, H, that's the perpendicular height, and capital R. Now, don't forget that we know the slant height of the cone. Don't forget we said what? The radius of the minor sector is the same thing as the slant height of the cone, which is 21 centimeters. Now, capital R, which is the base radius, we had 7 centimeters. And now we want to find for what? H. We want to find for H. And when you check this right angle triangle, if you want to find for H, you can just apply the Pythagoras theorem. So we can say that using the Pythagoras theorem, we say that the square of the hypotenuse must be equal to what? The sum of squares of the other two sides. So we can say that L squared, that's the hypotenuse, where the 90 degrees faces is the hypotenuse. So L squared equals H squared plus R squared, capital R squared. Now we know L to be 21 squared equals H. We don't know H, so H squared plus capital R is 7 squared. We group like terms. 21 squared minus 7 squared equals H squared. Now, how do we find for H? We just take square roots on both sides of the equation. So square root of 21 squared minus 7 squared. Let's punch the calculator and let's see our answer. 21 squared minus 7 squared. And this will give us 14 square root of 2. 14 square root of 2 centimeters. The question says we should approximate this to 1 decimal place. And we have 19.79898. So to 1 decimal place, you get 19.8 centimeters. So 19.8 centimeters. All right. So this is the solution for the question. If you don't understand, please play back the video for better understanding. See you and have a nice day. Massa tutorials, we see where mathematical literacy begins. Bye bye.